Low troglodytes. So the other day I was at Open Source in San Francisco, met a lot of cool creators, saw a lot of cool stuff, and I was talking to somebody about one creator in particular who was like, they wanted to do 4K video, they wanted to edit 4K video, so they said, but they didn't know where to start. Like, what kind of a computer do they need, how much power do they need, what kind of a processor, that kind of a stuff. So I have a whole bunch of devices here that I can test. So let's try to see how much computer do you really need for 4K video editing. So this is our first test subject today. It's an old Dell Latitude laptop that has the dual core 7th gen i5, 8 gigabytes of RAM, and a very weak Intel integrated graphics card. Here are the specs right here. If you're interested, you can pause to read those. And the first thing we're gonna notice when you try to do anything with 4K video is that even the preview playback is pretty slow. Like, this GPU just doesn't like 4K anything. It's happiest at 1080p. And it shows here, because even the preview is not great. And then we'll drag something onto our timeline here. Just a single 4K clip. Again, this is very high bitrate 4K footage. This is out of my Panasonic Lumix G7 camera, shooting at 4K, 30 FPS at 100 megabit per second. Very, very high bitrate footage. And this computer is not having a good time playing it back. It is really, really slow playing back this decent 4K footage. So yeah. So here we are trying to render out that footage on the timeline, doing a preview render. Normally you do this if you have lots of effects stacked up, but here we're just doing it on this basic footage. And even after I rendered it out, it's somehow worse than it was before. It's like bunching up and somehow playing back worse. Alright, so this is the benchmark. This is a standardized test file I made. We can compare all the devices we're going to be talking about today. It consists of 3 4K video streams. The first one is a green screen, so it's chroma key. It's chroma key applied to it. The second 2 have transform effects, so they're resized, scaled, and positioned on the frame, and then there's a picture below it. And this computer takes forever to render anything on the timeline. With 4K video, it's really, really laggy. Everything just takes forever. It's really slow. It's really painful to use. It's always running out of RAM. It's just definitively a bad experience, and you need something faster. Alright, so it's pretty clear that wasn't gonna work. You know, some dingus little dual core 7th gen i5, obviously not anywhere near enough horsepower. Also, only having 8 gigabytes of RAM is gonna seriously limit you. I mean, that's fine for doing like 1080p, like basic low bitrate 1080p. I mean, as I mentioned before, these are really, really large, like super high bitrate, you know, high quality 4K files, so yeah, no, you probably need something a little bit faster. So here's our next test subject. It's my Framework 13-inch Ryzen 7 7840U laptop. It's orders of magnitude faster than the previous device we were talking about. Here are the specs if you want to pause and read them. Yeah, here it is playing back just a basic 4K video file. Again, 100 megabit, you know, 4K. Absolutely no problems. It's playing back basically as smoothly as Kdenlive will go. Absolutely no problems. Here it is playing back a 4K 60 file. Again, it's not playing it back at 60 FPS because it's doing it entirely on the CPU, so it's skipping some frames. But again, perfectly usable, perfectly fine to edit this. So here we have the Framework actually playing back this 4K torture file here, and it's doing a valiant job. So if you want to do little tweaks and little edits, change parameters, it will be very responsive for that. And then here's our 30-second preview render. It rendered it out a lot faster. So again, when you're rendering stuff on the timeline, having an 8-core, you know, high-performance processor is about what you need, I'd say. At this level of hardware is about right for most people for what this is. So, clearly going from, you know, a dual-core i5 to an 8-core Ryzen mobile chip, 8 gigs of single channel DDR4 to 64 gigabytes of dual channel DDR5. You know, a much faster iGPU. We went from barely being able to play back a 4K video file, like at all on the timeline, to being able to play back, you know, 3 4K videos all on top of each other, like 3 4K streams at once with heavy effects, which was usable. I mean, it wasn't like perfectly smooth, but it was usable. And then if you render it out, which didn't take too long, given, I mean, it took a lot shorter amount of time to render that than like a basic 4K video took on the old computer, on the previous machine. So, and 4K 60 was fine as well. So I'd say for most people, just doing basic, you know, just cutting clips together, not doing too many effects, not doing too many transitions, this is probably fine. This is a good amount of horsepower. You probably don't need too much more than that. But what happens if you add even more horsepower to it? Will it get any faster? Let's find out together. So this is the final computer we are going to be taking a look at today. It's my desktop computer with a Ryzen 7 5800X 3D and an RX 6600 AMD graphics card with 32 gigabytes of DDR4, 3200 megahertz RAM. Here are the exact specs if you want to pause and take a look at those. And yeah, it's slightly slower than my Framework 13-inch laptop. Could be down to that the CPU doesn't clock as high and it's an older architecture. It could be that the RAM is slightly slower, so you have DDR5 versus DDR4. I mean, it's still perfectly usable. Like, up to this point, I've edited this entire video on this computer, and it was fine. I was happy. So, maybe this is enough for 4K video. It kind of entirely depends on what you want to do. Like, these renders and exports took just a little bit longer, but I was also doing a lot of other stuff on my computer at the same time. So who knows, we're gonna have to talk about this. So the final test I ran was how well can these processors transcode 4K 60 FPS footage, because, you know, maybe you export as a super high quality master file, you know, uncompressed massive file for, you know, the best quality, and then you want to transcode that final export to, you know, H.264 or AV1 or something that's easier to share and a lot more compressible and easier to share on the internet and stuff. And what we found for the Dell laptop is that it was going to take forever. You know, that first computer with a little dual-core i5 and, you know, 8 gigs of RAM, not happening. It was going to take forever. Basically, it DNF'd, like it just couldn't do it. And we already know that that computer is pretty much useless for 4K video editing anyways. Is what has been definitively proven. Now, the interesting thing is for the framework, for the, you know, this laptop right here, the 7840U, you know, it's a new CPU, it clocks really high, it clocks up to like 5.1 gigahertz or whatever, 64 gigabytes of very fast memory. You know, it was a little bit faster in Kdenlive in terms of, you know, doing the preview renders, the timeline renders, and final export was a little bit faster there. But the desktop PC, my desktop right here, the 5800X 3D, again, it's an older processor. It has a lot more cache, so that might help. And it's also able to use a lot more power, so it's able to do more, I guess. Was slightly slower at final export and preview renders, but it was way faster in the transcode test. Like, way faster for transcoding. So what have we learned today? Basically, you want a decent modern 8-core processor, so like a 5800X, 5800X 3D, something like that. The higher clock speeds are important, so in the 7840U, you know, in the laptop, this boosts up to like 5 gigahertz. Whereas the CPU in this computer, the 5800X 3D, only goes up to like 4.2. That helps, having higher clock speed helps. You want at least 32 gigabytes of fast memory, and a decent graphics card with at least 12 or 16 gigabytes of VRAM, I would say, especially if you're going to use something like DaVinci Resolve, which is entirely GPU bound, so it uses GPU compute to do everything. And yeah, that would about do it. Okay, bye.